Week 4, assignment on standardized normal curve. Question 1. John took an IQ test and received a score of 133. He would like to know what percentage of people score above his score. What can you tell him? IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So knowing that, I used the z-score method for that one. So I did 133 minus 100 over 15 equals 2.2. I looked at the chart and everything, got the numbers for that. And then I did 100 minus 98.61, which equals 1.39%. So for number 1, it's right here, z-score, get here, found the number from the chart, 100 minus that, and then 1.39% for number 1. Number 2, so I did the normal distribution curve for number 2, and then I looked at the z table and everything. So for number 2, it says in a normal distribution, what percentage of people have scores below negative 0.5 standard deviation, and then part B of that is above 0.5 standard deviation. So I looked at the z table for 0.5, I got 0.6915, so I did 1 minus that because it was negative. So 1 minus 0.6915, and then I got equals 0.3085, and I multiplied that by 100 to get 30.85% for part A. And then for part B, since it's the same thing, but on the other side, I just did 100 minus that, and I got 30.85, but I did 100 minus, I moved the decimal places over, so where it says 0.6915, it should be like 69%. So I got 30.85% again. So for question 2, part A and B, I got 30.85% right here. Number 3, in one distribution whose scores are normally distributed, John received a score of 44 and Peter achieved a score of 52. What percentage of people score between those two scores? The mean of this distribution is 40 and the standard deviation is 4. So then I use z-score again. So I did 44 minus 40 over 4, so that's 4 over 4, that equals 1. So John was at 84% on the normal distribution curve when you look at it, because that's plus 1. And then when I look for Peter, I did 52 minus 40 over 4, 12 over 3, that equals 3. Peter was at 99.5%. So for question 3, I go here. And then I subtracted 99.5 minus 84% to give me 15.5%. So the 15.5% was the percentage of people who score between those two scores. So my answer for number 3 is 15.5% in total. Question 4, SAT scores follow a normal distribution with a mean of 500 and a standard deviation of 100. Lisa obtained a score of 433 and Donna managed a score of 549. What percentage of people fall between those limits? So again, I use a z-curve, the z-score. So I did 433 for Lisa minus 500 over 100, and that gave me negative 0.67. And then Donna was 549 minus 500 over 100 equals 49 over 100 equals 0.49. So then I did so I looked at the z table, and then I found the numbers to plug in for negative 0.67 and 0.49. So I did, since it's negative, I did 1 minus 0.7486. So I got 25.14 for Lisa, and then Donna was 68.79%. So I did 68.79% minus 25.14 equals 43.65%. So 43.65% scored between those limits. And here's my work for question 4. So we find that for Lisa, find it for Donna. Let me find the numbers from the z table, and then subtract it by 1, and then in total we get 43.65%. Question 5, distribution A has a mean of 200 and a standard deviation of 25. Distribution B has a mean of 75 and a standard deviation of 10. On distribution A, Tom obtained a score of 204, assuming that both tests measure the same characteristic. Predict Tom's score on distribution B. So for distribution A, I wrote everything down. So mean was 200, standard deviation was 25, Tom's score was 204. For distribution B, mean was 75, standard deviation was 10, Tom's score was unknown. So then I did X minus X with the bar over it, over standard deviation, over equals X2 minus X with the bar over it 2 over standard deviation 2. So when I plug in the numbers, it's 204 minus 200 over 25 equals X2 minus 75 over 10. So when I get here, when I get to this, I multiply it by 10 so that this base can be eliminated. Yeah, I multiply by 10 so that this base can be eliminated. That's after I found the answer for this. So 10 times 0.16 equals 1.6 equals, so after I calculated this side, because I had all the numbers for this side, I had to find this side, so that's why I multiplied by 10. So then I did 10 times the answer of this, which was 1.6, so now that's 1.6. And then equals X2 minus 75, so then I add 75 to both sides, so X2 equals 76.6. And that's how I found the answer for question 5. Question 6 was basically like the same type of question. So for distribution A, mean was 200, standard deviation was 25, Don's score is unknown. For distribution B, mean is 75, standard deviation is 10, Don's score is 67. So I did the same thing and plugged in the same, like not the same numbers, but I did the same thing. So X minus 200 over 25 here equals 67 minus 75 over 10. So then I got X minus 200 equals 20. I made sure that I multiplied 25 from this side also to this side. So then I got X minus 200 equals negative 20. So then I add 200, and then X equals 180. And this is my work. Question 7, it's sort of the same, but to hire people for the top management positions, a company decides to administer an aptitude test to prospective employees and declares that it will hire only those persons whose scores fall in the top 2.5% of cases. The test results follow a normal distribution with a mean of 150 and a standard deviation of 10. Jose obtained a score of 164 and wants to know whether he will get a job in this company. If yes, explain why. If not, what score would he have needed to secure a job? So mean is 150, standard deviation is 10, Jose scores 164. So I did 164 minus 150 over 10 equals 14 over 10, which equals 1.4. Look at the chart. So I did X minus X. So then that's X minus 150 over 10 equals okay, yeah. So X minus 150 over 10. So when I did that, I had to multiply 10 to get rid of the denominator. So I did 2 times 10. No, it's not right. Wait. 1.4, I looked at the chart. Oh, so for 2 point, yeah, okay, so then I did multiply it by 2 because of 2.5 cases, so X minus 150 over 10 times 2 times 2. So I get X minus 150 equals 20 plus 150 plus 150, X equals 70. So Jose needed to score 170 in order to secure the job, but he scored a 164. And this is my work. Thank you.